Right, so if you remember last day we talked about connecting a circuit, right? And in this circuit I showed you that within a series and parallel, right? We also saw that the same current flowing in series but different current in parallel. Remember that? All right. So today now we want to take a look a little further into more the calculations now. All right. So we want to take a look at the relationship firstly. Let's see if we could find the relationship firstly between voltage, current, and resistance, right? So try to remember this value, right? The voltage reading here is 9 volts. So a 9 volts is being supplied, right? I want to remove one of these. Hold on. Right. So we're trying to get a relationship between voltage and current and resistance. So the voltage in this circuit, 9 volts. The resistance in this circuit, 10. Right? You can probably write it up. And current. Current is 0.9. So I wanted to figure out the relationship between VI and R. Right? This one again, voltage 9 volts. Voltage 9 volts. Current 0.9 amperes. Current 0.9 amperes. And resistance 10 ohms. And resistance 10 ohms. Right? And resistance 10 ohms. So what's the relationship between V, I, and R? Anybody? Right, so as we said, the V is 9 volts, I is 0.9 amperes, and the resistance is 10 ohms. How you relate it? Yeah. V over V is V over I by R. I mean this. Yeah. So how do we relate to that? How is I and R related to V? How is I and R related to V? Right? So when you multiply I by R, you will get V. Okay? So that's the formula. Make a note of that. Right? So that's the formula relating V, I, and R. V is equal to IR. Right? Online? So the formula relating V, I, and R is V is equal to IR. Right, using that formula, let's do some quick little things. I'm gonna change the resistance, I'm gonna put it all the way up to about 82. Tell me what you think current value is. What's the current value? When I put the ammeter there, what are you supposed to get? Yeah, volts is still 9. Volts is still 9. Yeah, you got that. 0.11. Altogether. Let's see if you're right. Look at the formula. B is equal to IR. So make I the subject. I is B over R. Let me see if you're right now. Correct. 0.11. Are you okay with that? Right, since you're okay with that, I am going to change the voltage now to about 50 volts. We're going to change it to 50 volts. Current reading is 0.61. What do you think the resistance here is? Voltage is 50, current is 0.61. Tell me what you think the resistance is. Online, you can message your answer as well. How much you get? 82? Right, okay. I didn't change it, so the same thing. 82 ohms. Are you okay with that? So basically, it just gives you the relationship between VI and R. Are you okay with that? Okay. Do I show you the others? Not right now, no? Let me come out of this. Let me stop share. I go back to the screen. Nice. So basically, we learned the relationship V is equal to IR, and that basically brings us to Ohm's law, right? So what did Ohm say, right? Ohm basically said, right? Ohm's law states that current and voltage, they directly related, right? Current and voltage are directly related. Okay? So it means that V is proportional to I. Right? For those who remember the little maps, as V is, when I take off proportional, I'll get equal and K. And the constant here, this constant here is your resistance. So we have the formula V is equal to IR. Right? So this little formula here is the Ohm's law. Right? If you get in trouble to make it subject of the formula, you can use this here to help you remember. To make V the subject, you cover V. To make I the subject, you cover I, and so on, right? But they should be able to handle that, right? And Ohm's also has this relationship for V and I. The graph looks like that, right? This is the graph of an ohmic conduct. Anybody could guess what it creates on a graph like this? Think about it. If you find the gradient for a graph like this, what is it equal to? Huh? 1? Why it equal to? Huh? It's not a value because I didn't give you any values. It's a quantity. What does what does the gradient for voltage versus current graph look like? Think about it. Anybody? 45 resistance. And what is V over I? And V over I is distance. And gradient is what? Gradient is whatever on the y divided by whatever on the x. So V divided by I is here. Right? Not 45 actually. Right? Copy it up. Right, how we doing this here, but I want to get this. You can get this both of each other, right? So here's what we need, right? This is the most popular set of information that we need from a graph, right? Voltage and current. So we need a circuit that will help us get voltage and current readings all the time, right? So I want you to think about it and tell me what this circuit has to have in it, right? So we have to design a circuit that will give us voltage readings and current readings, and then we're going to do it here. We're going to do it with problem. Think about it in the meantime. We're going to look for a circuit. Okay, got it. What is that circuit? What is the circuit that's going to allow us to find I and V? Huh? What we need? Well, no, we don't need a resistor. It will help us find the resistance in this circuit, right? But what we need? The first thing we need is a what? A supply, right? So we need a battery. What else we need? A switch. A what? What okay, wire. Connecting wires. What we connecting to? A bulb. All right, connecting to a bulb. Or we get current and voltage readings. Ammeter, and connecting the ammeter in what? In series. And we connecting the voltmeter where? In parallel. That's it. If I turn on this circuit, right, I will get one current reading and one voltage reading. Is that enough? Is that enough for you to plot a graph? No. How again the rest? Huh? What is somebody saying in there? Huh? Right. So if I add a resistor, I will get a second reading. Or I get a third and a fourth and a fifth. Keep changing resistor, right? So we use something called the variable resistor. Right? Remember I told you I had a symbol to give you? That's a symbol. It's called a rheostat or a variable resistor. Okay? It's called a rheostat or a variable resistor. So here's what you're going to do for me now. We are going to obviously come build a circuit here for me. Huh? I know if you get it graph because I don't want to blow the ball. I said I reduce the bar, exactly. Right. Who come in? I will. I'll do rock paper scissors. Right? One group versus this group. Right? Upside down. In that rock paper scissors. Whoever lose, you can choose to come in the build circuit. Ready? Ready? Yeah, you. I call it. I call it. Better tree. Ready? Rock paper scissors shoot. Right. It was one. Rock paper scissors shoot. Rock paper scissors shoot. Rock paper scissors shoot. And one all. Right. Ready? Rock paper scissors shoot. Rock paper scissors shoot. Who went? All you have to do. Come to your again. All right, so the other choose. Yeah. And it's choose all here. Come. All six. Come, Charles. Charles, right? Right, so what this person, what the purpose did for the here, the purpose have a circuit connect up already. But yes, circuit is up. Parallel, right? And okay, everything working in. So what all the other figure out, any one person cannot do the adjusted. I want to get current and voltage readings. Here, you don't need a rheostat. This is the ability rheostat. Right? By turning this, you can control the slight problem here is that our maximum current reading is what? 5 maximum voltages. So they can't get readings between them. Okay? So if you want to get a reading, you can make them plotted. Right? And then finally, go ahead. Do other thing. These four working, so stick with these four, right? I think this one working. You set it on the board, so you know everything going. Yeah, you don't need two of them, one about them. Right, so if I think there's something, I have to go. One about me. So the other, oh, you're already. And I could get why you can touch in there, good. And if you strongly have eating bones, it's on the this one could have. Anyone? Underneath the fact. This one will be. Online, the adjustability circuit, right? It's not defined for you. This one good. I don't want to take that. Still, I'm going to 30 volts, still connected in parallel. But one of the things that I used to do, like, I would put down all the apparatus first and then connect. So you know where it's just go in here and then put up the wires. Right, for some missing, yes, okay. I'm missing. But I would. Yeah, put it in. You know, it matter what side we go on. What's that? Yeah, it's connected, it's working. How are you gonna bring in the army stuff now? I want to bring in the army stuff. Right. Take this out. And I get those. Then I'll close the other stuff. Yeah, we just speed it in a bit. Right, but what do you do at this? I'd like to play that subject, show you that's. Right, here we have to make sure. You have to make sure that negative, going towards negative, positive, positive. Right? So negative here, negative connected, positive. This will be connected to negative, right? Positive. Okay, so so you use that, that's how you do it. Right? Right, now I'm on that. Somewhere on the line. It was working all the time, so what is many good. Sometimes, but it's not true. Sometimes. Anyway, we will spend time behind that. What's your house set up? Right, so what you have to do is lab everything you do. Right? So you have to test it. So the first thing I did, I tested to make sure the ball working. I tested to make sure this working and this working. But that working, you know, these two things working. I think why they do good. So if you add something now, so it now would be more than likely that why they adding something. Right, but these wires next to us, we want these wires not connected. Properly. This is basically how this is. Right? Supply, variable resistor, and these are connected in series, both are connected in parallel. All right? But when it's in its one, you can adjust the video start and they get different readings, I guess. Right, come on in. Well, yeah, you've got to do now. Come on now. Come just look, come just look. Something they come and do, we understand. Our time, just look at that. Yeah. Right. No, that's good, there's no auto exceptions or that. So they just connect it correctly. Yeah, like you do that right. Figure that. Check out if you go with the connected properly.
Yeah.
Connect, what we think connected in one. Parallel.
Always because now off.
Yeah, no, forget that, oh, no. But check and make sure the amines are both connected properly.
Yeah, I got out. I got out.
Right.
What? Body class.
But in terms of where things are.
No, but in the right position.
Right position. That's right. Let's check out the negative, negative. Yeah. Yeah, the negative to the negative. To the negative, and the positive. Right. So that part is good, right? So it should work, right? Sorry about the problem. Okay, go read that. Huh? In the right place to probably go wild, but right? So maybe the wires are just basically it's a good connected. If the wires look good, or you do it on your circuit, and you adjust the rheostat and you get them perfect. Right? You get about 6 readers, plot your graph, find reading. Okay, but yeah, there's a lot to define the resistance of bulb or resistance. Okay, so that's basically how it's all right. I'm not sure which wire I give it trouble. Upside down, I want to figure that out. I just will look upside. I can come here and figure that out. Right. Right online. Sorry there. So online, all we kind of did there is I just showed them how to set up a circuit, right? Take a picture a second. I'll take a picture of the circuit and I'm gonna send a group for you to take a look at this, right? I know it, yeah. That's the last thing. All right, nice. So we learned about the IV characteristics, right? So the IV characteristics, this graph here, sorry, this circuit here, is a circuit that you have to draw anytime you see, find the IV characteristics, right? Okay. There are some other things that we need IV characteristics of, like a diode and thing, but I'll make it do that later on. I'll give it that later on when we come to diodes. Nice. Let's take a look at now series and parallel. Kind of series and parallel. Right, online, if you're checking the group there, if you're checking the group there, you will see a picture of you'll see a picture of how to set up the circuit, right? Picture. Really upside down? Oh, picture. All right, have a class. That's cell class. All right, so you want to focus now on series and parallel, and here's where all our calculations going to start to come from, right? So you will see a bit of the past papers after this. Okay. Let's do a table on series and parallel. I showed you last class how to know if a circuit is a series of parallel, right? Right. This one probably the most important thing that you'll do in this electricity, right? Series and parallel. Series, parallel. You want to know how current behaves, how voltage behaves, and how resistance behaves. Right, do a whole table now. Do a whole table. Right, David, Reed, and we work on. And we online, eh? Oh, yeah, and we online. If you are, and you are not directly upside down, but I'm saying you can read it, it's floating from upside down. Hey. It's floating to the phone. Okay. It's one shot. It's in. One is. Aren't you?
I can see Abdul.
All right. All right, yes. Good. What did we learn about current in series? How does it behave? It's the same, right? Current stays the same in series. What did we learn about current in parallel? Try to remember when we did the simulation. Is what? It's vary, it's split up, right? Matthew, voltage in series. What's that one? All the answers right here, all the answers they need. And voltage in series? And voltage splits up in series. Right? Remember I told you it switch around, right? Voltage in parallel is the same. Okay? Voltage in parallel is the same. Right? Resistance, right? What you said, this one new. To calculate resistance in series, to calculate the total resistance, the formula is the add of the resistance, R1 plus R2. So if you have two resistors in series, you add them up to get the total. But if you have two resistors in parallel, you have to use this formula here. 1 on R1 plus 1 on R2. Okay? Or you can rearrange it. It's up to you. Or you could rearrange it. But I don't like to use that because this formula here I'm going to give you only works for two resistors, right? Product over sum. This formula only works for two resistors. If it's three resistors, you'll have to use this one on add on, one on R3. Okay? But I'll give it to you still because multiple choice sometimes you might see that. All right, so we're gonna practice it a little bit. Open your phone. Right, so remember these formulas, and of course, well, remember the one we did earlier in class, right? B is equal to I. All right, so let's take example number 1. I'm giving you a basic circuit. Copy that down and let's get a little try here. Right, copy down the circuit and let's see if we can find each one of those. Put what we just done, the total current and then the voltage. Go ahead and get the right answer. If you can, yes. Good circuit. Good circuit. Alright, so let's go. First thing first, let's see if we can find the total resistance, right? To get the total resistance, we have to figure out what the circuit, how the resistors connected. These two resistors connected in series. So we go to the series part and we see that total resistance is R1 plus R2, which is 3 plus 2, which is 5 ohms. That's okay? Easy, right? Part 2, how do we find current? Current in the whole circuit will be voltage divided by resistance. If we use V is equal to IR, right? So the total voltage is how much? 10, and the total resistance is 5. So the current in the circuit is 2 amperes. Next, they want us to find V1. V1 is the voltage here, right? So we know that V is equal to I by R, correct? What's the current flowing here? 2. Why? Because current in series is the same, right? Current in series is the same. So I have 2 amperes here and 2 amperes here. And the resistance, well, I know the resistance I'm trying to find. Resistances. Are you okay with that? So the voltage is 6 volts. Are you okay with that? So Jiran, if here is 6 volts, how much is here? If here is 6 volts, what's the voltage here? Voltage in what? Voltage in series splits up, right? So if 10 being supplied, and here is 6, and here is that much you? Everybody okay with that? See that, Charles? So the total voltage being supplied 10, and it will split up here and here. So if we worked out here is 6, we could figure out here will be 4, right? And current in this whole circuit here is the same. There's always going to be 2 amperes. Are you okay with that? Copy down. Let's go again. Okay. Try that then. Find the total current in the whole circuit, total resistance, and the current I1. Right? Dancing, you're okay with number 1. So it's circuit, yeah, and it's circuit is true, right? Right, take your time, try to work it out. Online, message your answers, right? Leonardo, message your answers. Alright, take your time, find each one. Let's see if we can work it out. Use the right formula, right? You have to use the rules, right? So these two resistors are in what, Charles? These two resistors are in series and parallel. these two resistors, how are they connected in series and parallel? Parallel. So the formula we're using is what? The one down there, parallel, right? Nice. Take your time, work it out. I am using the first one, right? Not the second one. And for the third part, for the second part, simple, right? The third part, what has happened to voltage in parallel, Matthew? Steady? Matthew? It's the same, right? Finish it. Finish. Last one. In total. So once you have total voltage and total resistance, you can find total current. But part three different. Part three a little different. Why now what voltage? Voltage is in parallel. Voltage is what? Look at that right there. Voltage what? In parallel. You know, just start on the session. Make a left. Yeah. But what's now what voltage in parallel? Same. So if it supplies 10, then the voltage there is also what? 10. Right? Ready? Let's do it again. Huh? So total resistance, I am using the 1 on R formula. So it's 1 on 2 plus 1 on 4. So 1 on R is equal to 3/4. But you can't leave your answer like that, right? This is 1 on R. So we had to flip it over. You'll get 4 and 3 volts. That's okay? current is voltage and resistance. Voltage is 10, resistance is 4 and 3. How much is that? 7.5. Everybody get that? Yeah. So now that you know current, we know that current in parallel going to split up. So that 7.5 will reach here and split up. That's okay? So we had to get I1. I1 is V on R, right? V is what? Voltage in parallel is the same. So the voltage here, here, and here is the same. So the voltage here is also 10, and R1 is 2. So the current is 5, right? Ashton, what's the current in the 4 ohm? What will it, if here is 5, how much is here? Huh? 5? I got it. Total being supplied is how much? So if here taking 5, here taking how much? 2.5. Question, David, right? David, question, David. David, why it is 5 going up here and 2.5 going here? Why is not the other way around? Why the larger amount going here and the smaller amount going underneath it? What is it? Now, I want to know why the larger amount going here and the smaller amount going here. Higher the resistance, smaller the current, or bigger the bigger the current.
Higher the resistance.
The right, so the high resistor, small current. Small resistor, high current. Y'all seen that? So you kind of know where your value is correct as well. All right, nice. What time is that finish? Oh, yeah, I've done so. I'll just do any homework. Keep doing any homework. You doing homework? Yeah. Now, as one time, before we go, there's one thing I would like to do now, right? Forget the circuit. Forget the circuit, right? I just want you to find the total resistance here for me. Right? We'll do more of these next day and then do class papers. Right? All I want you to do is find the total resistance of this circuit for me. This one is 2, this one is 2, this one is 2. All is 2. All right, now this one is 4. Do me a favor. Find the total resistance for this little circuit here. So you have to figure out, are these two in series or parallel? Are these in series or parallel? Okay? Let me see you try it. I'm giving you 1 minute. 1 minute and number 1 third again. I'll answer. Tricky, but somebody have answered already. That's correct too. 10 seconds again. Online. Send in nothing by. If you send something, Annalene send anything. Lindsay, Abdul, and Vinay will send that, not sure. Right, upside down. What do you get? One person get 2. What do you get? No, yeah. No, you're laughing. You're going to get anything. What do you get? Samira. What you get? I don't know. Yeah, I don't know. What you get? Remark. I don't know. 2. Chào tận thế. 2. On this side, what do you get 2? What do you get 2 here? All right, let's see. Right, first thing, what you have to do is learn to simplify your circuits, right? These two will become one big resistor, right? You're adding them up. So it will look like this. 2 plus 2, sorry, 2 plus 2 is 4, right? So the top is 4 and bottom is 4, correct? So we could use the resistance formula. 1 on R is equal to 1 on 4 plus 1 on 4, which is 2 on 4. And then flip it over to get R. That's okay? So the answer is 2. Right now, I thought I'm going to give all the info because but the last week I'm going to give you a paper system because we covered mechanics, thermal wave, and electrical ones. It's the radioactivity video. All right, so I'm going to give you something like that for homework. All right. So next day we continue from right here. Please remember these things, please. All right, on Tuesday we continue.